Hello everyone, my name is Sebi, and in this course we're going to learn how to create procedural characters. We will generate them in Houdini and render them in Unreal Engine. In this course, what will be procedural for the character will be the generation of the mesh. And we will just use one skeleton, and later on, maybe in next courses, I will think of how to create different skeletons as well. In the context of computer graphics, there is a lot of ways of defining a character. Many of these ways really come from the nomenclatures of different programs and software in order to create them. In Houdini, we call them characters. In Blender, sometimes they are called armatures. In Unreal Engine, we call them skeletal meshes. From all these names, I like the most skeletal mesh because a character is really composed by a skeleton and a mesh, and this mesh is driven by the skeleton. Once you define a character like that, a character can be anything. It can be a tube, it can be a dog, it can be an animal, it can be really become anything that you need to create. Other synonyms for skeleton could be the armature or the rig, and the rig coming from the process of rigging a character, where we are connecting the mesh and the skeleton together. A mesh can have a lot of properties. In this course, I will just talk about the fundamentals of them. The topology of the mesh is the most fundamental of all, is what type of polygons comprise the mesh. Depending on our topology, our deformations on the animations of the character will change dramatically. Because our output will live in a real-time environment, we need to understand the levels of detail. This technique will allow us to reduce and take away detail depending on the distance that we are from our model, and is stored within the character itself. This means that we can have a lot more characters that can run in real time within our game. The UVs are also an essential part of any mesh, and it's a way to map the vertices of the mesh into a texture coordinate map. This will allow us to create textures, even though we are not going to use them in this course. It's important to understand that this is a very important part of a character in order to create detail for it. Any mesh can store vertex colors in their vertices. Depending on the resolution of the mesh, we will have more or less data available to store. In this course, we will store the ambient occlusion, the concavity and the convexity of the model, and we will use it to shade it at the later stage of the project. The skeleton is a hierarchical structure that contains joints and orientations, and it will drive our mesh. To connect the mesh and the skeleton, we are going to use weights. They will be automatically calculated and not very accurate, but it will speed up the process a lot. A weight is an attribute that connects a point to a specific set of vertices of our mesh. This allows to move the point of our skeleton and it will deform the mesh. With this, we will be able to create animations like this walk cycle. And depending on our capture weights, it will behave in different ways. And as we saw before, the topology of our mesh will also be very important for this process, because depending on the amount of vertices and the shape of them, will react in different way. The resolution of our mesh and our skeleton should be considerably similar. Depending on the animations that we want, we don't want to have a very high resolution skeleton, because it will be a waste of resources. There is other circumstances where our skeleton resolution should be higher, and it all depends on the type of animation that we want to achieve.